Good morning, everyone, and thank you for attending the AECB webinar today. And this webinar is an introduction to the AECB Building Standard, being led by AECB Expert Advisor Mark Siddall. Mark is a technical expert advisor for the AECB, as well as an AECB trustee. And before becoming an architect, Mark actually worked as a labourer on building sites. So he's seen both sides as an estimator for a house builder and as an architectural technologist. Mark is one of the most experienced passive house architects in the Northeast. He's a director of architecture at Durham-based LEAP, the lovingly engineered architectural practice, and co-author of 12 peer-reviewed journal and conference papers and 4 passive house design guides. He's also the chair of the REBA Northeast Sustainable Futures Forum. So I'm going to hand you all over to Mark now so he can do this presentation. And over to you, Mark. Thank you.
Right, thank you, James. So hello and welcome. As James has said, today we're going to be going through a quick review of the AECB Building Standard in its current form. And for those of you that are AECB members, you'll have seen that it's expanded and consolidated itself over the last few months. So, right. So a bit about me, just as a quick bit of context. The thing that really set me on my path, should we say, as an architect, thinking about environmental issues was, well, firstly, an awareness of climate change, of course, and the impact upon biodiversity. But also I kind of realized it was something of an ethical imperative, as an architect at least, because of the energy performance gap and the failure of our buildings to deliver the performance that we expect of them and that we explain to our clients that our projects are going to deliver. So we need to make sure that's addressed if we're not going to be defrauding clients in the future. Then, of course, as I say, thinking about the various different generational issues there. So family. And my daughter is always, the next generation is always firmly in my mind's eye through Hannah. And then that obviously leads us into some of the more recent kind of conversations with Greta and her emphasis on addressing the climate issues. So my framework of thinking is if you're aware of a problem, then it's your responsibility to act. Or in Greta's words, I want you to act as if your house is on fire, because it is. So the AECB Building Standard itself breaks itself down. There's the building standard is basically a header, and underneath that there is a core standard which relates to energy, and then there are some complementary and voluntary standards that sit underneath that, which you can include within a project or a framework as required. So basically we've got energy is the core issue, then daylighting, lifetime carbon, and the water standard. And we'll be touching on each of these kind of key kind of platforms during the course of today. Quick little bit of history. I'm not going to go into this in too much detail, but basically the AECB building standards were first developed in 2005 and were talked about as being the gold standard and silver standard. Then in 2007, the AECB ushered Passivhaus into the UK and incorporated Passivhaus as one of the stepping stones in the building standards methodology. 2008, Nick Grant, Alan Clark, and Dr. Judith Thornton developed the AECB water standards. Then, with growing awareness of some of the issues and the problems that arise with trying to design zero carbon buildings, as the gold standard was dropped, and we've got a bit of out the sequence things here. The Passivhaus Trust was launched in 2010 via the AECB. And more recently, the AECB Silver Standard, which was the only kind of remaining standard of energy standards that were left in the overall remit, that was then renamed the AECB Building Standard, and we've then brought in other standards beneath that to support it. You can see here that kind of there's a range of different building projects that have achieved the AECB Building Standard: social housing, new build, retrofits. You've got all of the different options there, And there are school projects as well being realised to the building standard as well these days. The AECB Building Standard itself has its set of targets. Now, basically what we're talking about is a space heating demand target of 40 kilowatt hours per metre square per annum. And this is calculated using the PHPP, which is the Passivhaus planning package, and all the associated elements of the Passivhaus methodology. And what this means is that the primary energy demand is tied into PHPP and its calculation methods, and will be updated as and when PHPP is updated. And more recently, we're now introducing the PER under the umbrella of the AECB Building Standard, whereas previously that's been excluded. In terms of air tightness, what we see is a relaxation compared to Passivhaus. So we have an air tightness target of 1.5 if we're using MVHR, or if there's MEV, then an air tightness of 3 air changes per hour is acceptable. In terms of thermal bridging, then we're talking about minimizing thermal bridging so that using Passivhaus methodologies, you can achieve zero thermal bridging. Now, what this means is that in practice, anything that achieves less than 0.01 watts per meter Kelvin is a thermal bridge is considered thermal bridge free. Now, if some of the things I'm talking about here are a little bit Greek, then really that also, don't worry about that. That's where your Passivhaus designer, your certifier, I should say, will come in and support you in that process. We'll talk about that a bit more in a moment. And then also in terms of preventing overheating and summer discomfort, then just like Passivhaus, the backstop kind of threshold is 10, though less than 5% is what's recommended. So what does this look like in practice? Now, I've worked on a number of different projects and done various different analysis for clients, and I've created this quick little table which is got a lot of information on it, but I think you'll find it somewhat useful. You'll be able to come back to it in due course when this video gets uploaded online. But basically what we can see is, first of all, on the leftmost column with MEV at the top, so mechanical extract ventilation, we talk about an air tightness target of less than 3 air changes per hour at 50 pascals. Now, what we have here is, in fact, the model itself actually used ended up using an air tightness of 1.5 to try and achieve the space heating demand target. Now, what's interesting here is that you can see that we've got some fairly high standard U values, and we're still this is based in the northeast. For a pair of semi-detached dwellings, we're still struggling to achieve the AECB Building Standard. Okay, and that's an important thing to recognise. So there's an emphasis here that can be taken as looking at trying, maybe in the right climate, in certain climates with certain buildings with quite a poor form factor, like semi-detached, then MEV may or may not be appropriate and need some further analysis. But if we move over to the next column, then what we can see is if that semi-detached unit had MVHR and an air tightness of 1.5, the U values become somewhat more relaxed. We can include double glazing, and we're getting the space heating demand target down to less than 40 kilowatt hours per meter square per annum. However, to satisfy the primary energy and the PER targets, then we're looking at including some renewables to help get over the line. Because whilst we've satisfied the space heating demand target, the target for the primary energy and overall, or PER overall, still needs to be addressed. Moving further over, we can then start to say, well, how about if we try to address the primary energy or PER by the building fabric alone, or with a greater emphasis on the building fabric without the need for renewables, I should say. Then what we can see is that the air tightness target is still 1.5. We've got some more onerous U values here, and we end up with a space heating demand somewhere in the region of less than 20 kilowatt hours per meter square per annum. The heat recovery system has got an efficiency greater than 75%, and we're using the specific fan power is less than 0.45 watts per meter cubed. In all those circumstances, the overheating was less than 5%, and that was achieved by basically applying the AECB daylight standard in terms of getting the window proportions sized appropriately, so we've not got too much in terms of solar gains, and also by using the water standard to address issues associated with primary energy and heat losses from those services. If we move to the terrace of 5 and the terrace of 8, then what we can see here is that the fabric U values can be relaxed quite considerably. So having a good form factor, as Passivhaus designers would think of it, a good form factor really works in your favor. In this particular case, both of these terraces include MVHR, but because you've got the relaxed fabric standard, you can see that you can start to get into a position whereby mechanical extract ventilation may be something that could be considered in some of these more northern climates. As we move further south, you'll have to review this in more detail. But so this is just a quick headline to give you an overview of how different things might trade off on your specific project. And if you've got any questions about this, we can pick those up at the end. Okay, so why would you want to build to the AECB Energy Standards? Well, first of all, let's say that not everybody's brave enough to start with a Passivhaus, and even though that I think many Passivhaus designers would say that it's no harder necessarily once you've got the experience, it's appreciated that some clients may be a little bit more risk averse in that respect, and they may also have concerns about build costs, whether they're real or otherwise. So that's some other further thinking there. And then in terms of potential lower costs, well, when the certifier is the designer, the architect, engineer, then you don't have that third-party cost that would be introduced necessarily. But there are some swings and roundabouts to that, which we can come on to later. And then also, if you have a near-miss Passivhaus that failed because of it didn't achieve the air tightness targets, then the AECB Building Standard can become a suitable option in this respect. Further thinking on this would be that it gives you more flexibility. You've got different trade-offs and opportunities to seize upon depending upon how you perceive management of the building assets themselves. If it's a self-build, you might be going down one route, but if you're a local authority providing social housing, then you'll be thinking about various different other kind of requirements. So we've got back a bit backwards. We've got air tightness and MEV, smaller homes in the UK, so we've got more challenging form factor. The less onerous space heating demand target of 16 to 40 kilowatt hours per meter square per annum. So that we've got a range there in terms, so that gives you the flexibility, which allows you to have some more relaxed approaches to achieving the PER standards. And but what this would encourage also is more kind of thoughtful use of energy efficient appliances. One of the most cost-effective ways of reducing energy use is not by buying renewables, it's actually by getting energy efficient appliances. And this is where we get one of these should we say split incentives here between the building owner and the occupant. And energy efficient appliances are often more cost effective per kilowatt hour saved than the bolt-on renewables. So placing more emphasis on efficient appliances is always a good thing. In terms of setting up PHP, the Passivhaus planning package, which is used to underpin the design, the assessment of the design and the building. Key things to recognise here that all boundary conditions influencing energy performance are as the PHPP manual, and this includes ventilation and MVHR. And when on the verification sheet, then you would basically be setting it up as I show over here on the right hand side. So you set it up as a PHI low energy building in the in a classic format with the verification for primary energy or renewable energy, depending on your choice for the project. And then as a new build, more often than not, though, we'll talk a bit about retrofit later. So the introduction, excuse me, the introduction of primary energy into the AECB Building Standard. Basically, what that's doing is recognizing that our energy grids are changing, and that we are now, carbon emissions from the electrical grid is reducing. And once we get to the threshold of, should we say, well, the government's target of zero carbon by 2050, then how are we actually going to get through the winter kind of seasonal gap? We've got to store electricity, we've got to store energy in a format that will allow us to get through that winter period where we don't have the same access to solar energy, for instance. So what this means is that we then need to have storage facilities that are capable of satisfying that demand. And the PER, the primary energy renewable, is the methodology that the Passivhaus Institute have developed to reflect this kind of future planning of the electrical grid infrastructure. For the AECB Building Standard, when we start to think about modified U values for windows, for instance, then we need to be mindful of the comfort standards that we're also seeking to achieve. So here, the standard recognises the importance of satisfying ISO 7730, which is a comfort standard, and therefore thinking about radiant comfort, downdraft risks, and stratified air temperatures all becomes key. So what we can do in these contexts is we need to think about how our windows are, often it's the windows in these instances that would provide an issue. So we've got to think about how we are going to provide high standards of comfort. So we can do that in one of three different ways, really. Thinking about the window U values, thinking about the putting radiators, emitters underneath the windows, or using shutters and curtains in certain circumstances. Though the problem with shutters and curtains is that you can still get the downdraft during the daytime. So they're not necessarily a reliable response there. With windows, I've dragged out some research that I did from a number of years ago, 2008, and this, just to help people make in their decision making. So what we've got here is this is some analysis I did based upon some research by Per Heiselberg, looking at downdrafts from vertical surfaces. And what we can see here is that we'll just look at the magenta line, which is for a -5 degrees Celsius design temperature. And what we can see along the horizontal axis is the height of the window, and on the vertical axis, we've got the U value. So what you can do is you can look across at the height of your window, go up to the magenta line and track across to your U value and find out what the indicative U value would be to avoid drafts and discomfort. Now, this might work purely in the context of avoiding drafts and discomfort, but we've also got to be mindful of condensation risks. So the AECB Building Standard has a backstop U value of 1.4 for its windows, and that ties in neatly with avoiding condensation risks. So the area that's above, the U values that are above 1.4 are excluded from use. Your maximum window U value would be 1.4. In terms of submitting your AECB Building Standard project, then for the energy side of things, then what we're talking about, there's a host of criteria that we have to meet in terms of submission documents, and that's all available on the link down below. More accessible if you just Google AECB Building Standard and follow the links through. But this is on the members only side of the information of the guidance for the AECB Building Standard. So I'm not going to go through these in detail, more recognizing that this information is there, and that there are some key requirements both in terms of drawing, specifications, and photographic evidence as well. So who can certify your project? This is one of the kind of key questions that we often get asked. And basically what we're talking about are Passivhaus certifiers are very well suited to certifying your project. Experienced certified Passivhaus designers that are on the Passivhaus Institute's register, so they're maintaining their CPD. You can also, people that have passed the exam, the Passivhaus designer or consultant exam, and have experience of delivering Passivhaus projects. Then they're also, of course, capable of delivering that because they're maintaining their experience in delivering actual projects. And many of these members are members of the AECB. So your certifiers, you can find them by looking on the AECB members directory. If you're interested in becoming an AECB certifier, then you can go to passivhaustraining.co.uk and you can become a certified Passivhaus designer. So who can design your project? Well, ideally, we would argue that it's going to be someone with experience of the AECB Building Standard or Passivhaus, because they understand, the nature of the requirements, but also people that have delivered high standards of airtightness on their projects and have undertaken post-occupancy evaluation, building performance evaluation on their projects. They show a certain dedication to wanting to know more and know how to do things. So look for those kinds of people as well, in case you're in an area of the country where you haven't got anybody with direct experience. Who can build your project is often another question. There are a growing number of Passivhaus certified tradespeople, and again, many of those are AECB members, and also experienced contractors that have delivered AECB Building Standard projects or have got good air tightness results, and the likes. So that, that's more to think about there. And experienced certifiers can also train the tradespeople for a specific project, though that obviously tends to work better on a larger scale project rather than a small one. Again, if you are interested in becoming a qualified tradesperson, then again, becoming a certified Passivhaus tradesperson is the way. So go to passivhaustraining.co.uk. In terms of applying the AECB Building Standard to retrofits, well, currently there are pioneers that are using the Energy Standard to underpin their design. But when the Carbon Light training program, retrofit training program, recognises that there are some issues with that in terms of making sure that moisture issues are also addressed. So currently the AECB is kind of updating and reviewing retrofit standards, looking at component methods that can work with buildings, and also making sure that there's a good, strong focus on addressing moisture issues that can arise and do arise in a retrofit scenario. So watch this space for that. One of the questions that we often get asked in the technical committee is about working out the costs associated with fees and how much it costs to certify. And I'm not going to go into pounds, shillings and pence. That can be addressed on the website. But I just wanted to spend a little bit of time talking about some different approaches that different people have used on different projects to suit different client requirements. So in some circumstances, a client wants to certify every single individual dwelling as an independent certification process. And that's more time consuming because even if you've got the same house type, it may have a different orientation, and that can have its own set of impacts. So, but that is possible and can be done. So you've got a dwelling by dwelling approach. Then you can do, then you can certify by a dwelling type with an energy subtype. So what that means is that if we have this as a notional terrace here, these three red boxes, then what we can have is we've got two end terrace types with the same configuration of windows, same orientation, no windows on the gable ends for argument's sake, and therefore they're comparable, and therefore these can be kind of energy subtypes of a particular house type, if you follow. And so now you've reduced the number of models that you have to build, which can obviously reduce the cost of certification, both in terms of the cost, the certification fees that are payable to the AECB, but also in terms of the amount of time that is undertaken developing the models for certification as well, and pulling together all of the information. So this is a lower cost approach. And then the least cost approach, the one that we would generally recommend, is the building by building method. So if you've got an entire terrace, you would certify an entire terrace rather than the individual dwellings in it. And that's the lowest cost approach. It requires the least amount of effort to demonstrate compliance. So that's an overview of the different approaches to certification and cost modeling. Okay, so in addition to the AECB Energy Standard, there is the daylighting standard. And this very neatly works with the Energy Standard because we're talking about getting the windows right sized. So we're not oversizing them for costly solar gains, and we're not undersizing them either. So daylight factors are nothing new in the UK, at least. The calculation process can be very simple and very quick. It was developed basically in the 70s and 80s by the Building Research Establishment in many respects. The daylight factor is basically a ratio that represents the amount of illumination between inside and outside, that relationship between inside and outside. There are different ways of doing these kinds of calculations. And there's a number of different pieces of software that are there that have been listed that you could use. But there is the AECB daylight calculation tool, which we'll come on to in a second, as a way of proving compliance. So the basically it's a static measurement, so it's not dynamic. It doesn't really take into account orientation. The premise is that it's a standard overcast sky, and then we're looking at the relationship between that standard overcast sky and the amount of light that's inside the building. So it's, at certain times of year, you're going to get the same ratio, but you'll have more light in, and at other times less. Now, the key thing is, why would you want to consider a daylight standard? Looking at winter well-being in terms of reducing seasonal affective disorder, achieving summer comfort, so avoiding overheating risks, avoiding glare and gloom, that contrast that often takes place, and also reducing the amount of electrical energy demand, which obviously features in your primary energy demand target, and also getting the right sizing of windows so that you're not putting more window in than you need to when you're on a strict budget. There are several ways to calculate daylight. None of them are perfect. And when designing with daylight, consideration of glare and direct sunlight can be annoying in a work circumstance, but can be kind of relaxing and pleasant in a residential scenario. So we've got to think about how our buildings are going to be used, and make sure that we're concentrating on the actual practical delivery of a project, not just trying to tick a numbers box for the sake of it. With daylight modeling, then it's only really as good as your inputs. So thinking about the shading objects outside, looking at the true area of glazing that the sunlight will be coming through, not through, it's not the structural opening. We've obviously got a window frame there, so we've got the size, the area of the glazing that we need to think about, the solar transmittance of the glass, and in terms of the daylight, and also any kind of surface reflectances internally. If we've painted all the walls black, it's going to feel quite gloomy, regardless of whatever we do with the windows. So it's important to make some sensible considerations there. In terms of the AECB daylight standard, then again, as I've mentioned, it's a steady state model based upon BS 8206 and with reference to other BRE standards. What that means is that it basically provides a good standard of an adequate standard of daylight for 70% of the year between 9 o'clock and 5 p.m. And then for an extended period, it provides acceptable daylight between for up to 80% of the year between 10 a.m. and 2 p.m. Another consideration is daylight uniformity. So you can get all of that daylight in, but you could still have quite a gloomy room if it was too deep and dark at the back. So daylight uniformity considers this. And what we're targeting is making sure that the lighting uniformity in the room is more than 80% in all of the habitable rooms. And the calculation method, because it goes back to the British standard, can also be used in BREEAM and HQM, Housing Quality Mark. So if you're using the AECB Building Standard, and you are also looking to integrate it with some of these other standards, then you've got some common kind of points of reference there in terms of daylight calculation methods. In terms of quick overview of some targets here, but generally what we're talking about is in kind of kitchen and utility spaces, we're talking about a 2% daylight factor. In the living room, dining room, and studies, we're talking about a daylight factor of around about 1.5, and in a bedroom, we're talking about 1%. And these figures generally work out quite well. And in my experience, at least here in the Northeast, if you target these daylight factors, then we have some very low risks of overheating in the summer seasons. And then this basically then, once you've done all of your calculations using the AECB daylight calculation tool, then it basically produces this verification sheet. And you can see how we are looking at the various different stories, the rooms, the daylight uniformity, the daylit area. We've got the target daylight factors and what's been achieved in practice, and then a summary, which then says whether it's passed or failed. So it gives you a quite simple review in terms of looking at compliance on a room by room basis. As a quick start, basically you can, using the daylight modeling tool, which comes with PHRibbon, then you can model some prototype rooms and check out the window design proportions at an early stage, and then you can refine that and streamline that with your PHPP workflow. In my experience, one of the best things to do is, once you've gone through and used the tool and come up with it, developed a design and implemented it in practice, go back with the light meter, check the daylight levels outside and inside, and then get some information about how that's performing in practice. Monitor the temperature within the building for a period of 12 months or more, so that you can be thinking about any overheating risks and start to analyze that data, and then use that to start to kind of calibrate your approach to using these tools. And that's a really important part of the design process. The water standard I mentioned earlier on. Basically the water standards. There's a technical background that sets the which is volume 2, and volume 1 is kind of all the core information. I'm not going to be going through the individual details about the standards, but in terms of setting the context, what was recognised is that domestic hot water use accounts for a very large amount of the carbon emissions associated with water use. So we've got to make sure that we're addressing that in an appropriate way. The performance standards basically look at individual appliances, so taps and baths and the likes. And the water standard, when it was introduced, has actually gone on to influence the development of the current building regulations and the way that assessment methods are used there. Basically, what we find is that it's a cost-effective approach, and it's very much user-focused, thinking about the occupier and user's comfort and well-being. There's no point installing a tap that has got a very low flow, but you have to wait 15 minutes for the hot water to arrive, and you're just going to get frustrated and rip out the tap and replace it with something far less efficient. So there's a whole systems approach that is considered when addressing the AECB water standards. And that means sizing the pipe work appropriately as well. So addressing those issues that designers can address. We can't legislate how much water people use in their homes, but we can make sure that we deliver a good standard of building and in the process. And it's there's a cautious approach towards innovative technologies. It's not to say that innovative technologies are frowned upon, but you've got to think carefully about them, and you have to be very rigorous in terms of making sure that they're going to work on your project. So here we have one photograph from a while ago, basically looking at how the Code for Sustainable Homes was leading to baths that were really not suitable for use. People couldn't get in them, and so there were some issues there. And then also on the right hand side, we can see how you're having to run the water because of the length of the pipe and the diameter of the pipe. You're really running water for a long time to get hot water to people's hands. Again, that's not something that the AECB standard kind of supports or encourages. So that means that we're focusing on the appropriate design of dead legs, and that means the length of the pipe between the outlet and the point where it's the storage cylinder, or the point where the water's been heated. That's got to be managed in an appropriate way so that we're minimizing the volume of water that's stored in there. And we're also mindful of pressure losses in the system as well, because we often end up using micro-bore plumbing. And again, this is something that certified Passivhaus designers that have gone through the Carbon Light training program will have a good understanding of. And of course, by addressing the amount of energy that's used and lost through dead legs, that also reduces the impact upon the primary energy demand in a property as well. The appendix of the water standards gives a full schedule of the requirements of what's expected to satisfy the AECB water standards. And you can create a simple worksheet table that can allow the application on a project basis. And one of the things to do is to basically undertake measurements and prove and demonstrate that you've actually satisfied the performance requirements. So if you specified a 2.5 litre per minute flow, then you can actually use a weir gauge to go and measure that, or that's what the standards would require. You'll go and check that and verify that that delivery, performance has been delivered in practice, so it's not just a theoretical thing. Okay, in terms of a bit of a quick start to the water standards, I should flag that Harry Paticus from Arboreal Architecture first kind of proposed this kind of quick start guide. So basically what we're talking about here is as a designer proposing the water standards to a client in the briefing stage, RIVA stage 1, carrying out some early research to check the water pressures on the site and establishing whether there's any water stress and in the area, or any water hardness issues that need to be considered. Working with a good services engineer, AECB Carbon Light trained Passivhaus designer is kind of very useful in terms of thinking about those dead leg designs and getting the services designed properly. Because making sure that the pipe runs are as short as possible, and making sure that will influence room layouts and the relationships between your storage, hot water storage, and the rooms that are demanding it. And that's often overlooked in a lot of dwellings. So thinking about that at an early stage. In a broader context, thinking about landscape proposals in terms of collection of water and using drought-tolerant plants, and basically using the checklist, which I just mentioned from the appendices, is basically provides you with a list of good practice targets to think about. Having a toolbox talk on site with the plumber is also key, so that they don't go and install inappropriately sized pipes. So you need to have properly designed drawings, adequately specified pipes, and they need to know where they're going to put them and why they're putting them in there. Some time needs to be allowed for that commissioning process to make sure that measurements are taking place to check the flow rates. Finally, we've got the AECB Lifetime Carbon Standard, which is basically looking at the embodied carbon and the whole life carbon. Again, this is basically supported through PHPP, just like the daylight standard. And the requirement is simple. There's no, it's basically produce and develop 2 operational and embodied carbon calculations, and then basically implement the one that's the most optimal strategy. And at the moment, that's because it's too early days to start to specify a notional target and numerical target. But this does allow an evaluation process to take place. And it's that kind of reflective design process that we're encouraging through this. PHPP, as I say, the tool that's used for this assessment really works with PHPP. So you'll be using PHPP to develop the energy model for the building standard. The ribbon can then be used to support that calculation process to deliver daylight and the lifetime carbon assessments. And that's that. And if you want to know more about the ribbon and how that works, then Tim Martell has already done a number of different webinars on PHPP and the different modeling tools that it has within it, and that's all within the members area. So I'd encourage you to go and look at that if you're a member, and if you're not a member, then join up, and then you can get the background that you might require. So in this closing phase, then really what we're asking is, how is a project certified? What's the process? So basically on the left-hand side here, we've got a design development phase, we've got project team actions, should we say, we've got formal reviews, and we have planning and building control kind of relationships here. So the first step, we would be thinking about developing a prototype model. And that would be achieved through, you can do that beforehand. Now, whether thinking about the form factor, getting that right, that could be some simple sketches on a napkin, could be supported with an early stage PHPP model, which at an embryonic stage. Getting some, thinking about the construction methodologies that are going to be used and selecting the right kinds of products in the general form, feeding that into the PHPP, to kind of optimize the design and refine things a little bit further, and then undertaking an initial PHPP design check at least once, before the planning application. Normally, I personally would be expecting that this would be an iterative process, and as you're helping to inform and refine the design, then you'd have built the main model and then tweaked it in the process before the planning application. Next, we are looking at moving towards a kind of a full verification model. So this is now thinking more about primary energy issues. Now, in truth, there's depending on the approach that you're applying to your AECB Building Standard project, you might want to be developing a more detailed model at the planning stage, because if you're thinking about a renewables approach, then obviously that has an aesthetic kind of factor that needs to be considered, and that needs to be borne in mind. If it's mainly fabric related, then it can be a scenario whereby the verification is, in terms of PER, is developed after that at a later stage. And again, there's an iterative process here, looking at the design, refining the systems and the selection of products, and before a building regulations application would be made. And then we move on to that final phase, which would be full technical verification. So you're developing any further construction details, refining things, making sure that you're considering any issues in terms of air tightness and thermal bridging that haven't already been considered, refining your PHPP model in that process. And then eventually, once the building's been constructed and commissioned, and you've got air tightness certificates, you've got commissioning reports for the ventilation systems, and all that information's been pulled together, that's when you can start to move towards that final kind of the formal review in terms of certification processing, tidying up any loose ends, and then you would be able to submit the information, the body of information, to the AECB through the Low Energy Buildings database, and then you would be able to get your certificate. So in terms of declarations and submissions, then it's important to recognise that the onus sits for certification sits with the certifier. So therefore, it sits on the professional indemnity insurance of the certifier, and that's where and it's that liability that, should we say, encourages them to do the right work. Because if there's any kickback, then it's their liability that's at the end of the day. The AECB Building Standard itself is based upon a declaration. So the certifier is declaring the performance of the building that has met the standard, and on the basis that it's met the standard, then the certificates can then be issued. The verification sheets for energy must be kind of uploaded along with other supplementary information which I highlighted earlier on. But if you're also including daylight standards or lifetime carbon or water standards, then you'd basically bind those together into one PDF and then upload that as part of the verification sheet. And that all goes onto the Low Energy Buildings database. So basically, in terms of the Low Energy Buildings database, that's held and owned by the AECB. So if you're not already registered in terms of registering a project, you would need to register for use on the website, log in, and then in your account, you would then select AECB Building Standard as an option, and then you would fill in the requisite information. And at the end of that process, you're able to then get your certification certificate, which looks something like this. So it's a fairly simple format. It states that the targets that have been set and achieved, and who the certifier was, the owner, the architect and designer, the contractor, etc. So some of the challenges that can arise, if you're looking at a design and build contract, for instance, who would be the certifier, and would that certifier then be novated to the contractor? In which case, can you be as confident about that certification process? Without third-party independent certification, is it appropriate for the contractor to self-certify, or should the client be retaining the certifier as an independent third party? It's a choice that the client should be making. The wide range of choices means that that can be available in terms of trade-offs between ventilation systems and renewables and things, means that there's some more design time that has to go into the design process compared to, say, a passive house, but it's no more kind of thought-provoking than a building regulations submission would be. And then one of the questions which can arise sometimes is, will comfort be compromised by adopting the AECB Building Standard? And as I think I've tried to address earlier on, the answer is no, it shouldn't be compromised, because you're specifying the windows appropriately to in terms of avoiding cold downdrafts, or you're putting radiators in the right place, or doing some of the design methodology that will achieve the standards of comfort that are required. So in terms of the next steps, if you're thinking about how can you get help with your project, then first of all, as a client, then decide that you need the AECB Building Standard and it's right for you. Then appoint a suitable and experienced AECB certifier. And if you're a certifier and you're in doubt about the quality assurance, then it's basically as per Passivhaus, but using the space heating demand targets and air tightness targets as amended. If you've got any further questions, then please feel free to email the AECB at contact us at aecb.net, or AECB certification at aecb.net. Okay, so that's a quick overview, 45 minutes, we're doing okay there. How are we doing for questions, James?
Well, Andy's actually kindly answered quite a lot in the background for us. So first question from Tony Curran. Has anyone been sued for not meeting promised energy consumption?
Not that I'm aware of in any part of the world. I think that I'm not aware of anyone. But what we've got to recognise here is that you've got low consumers and you've got high consumers, and so any one dwelling is not representative. It's actually the average which is important. So that's how I would actually kind of advise there. Now, you obviously if a building is built in a way that it in its own right does not perform adequately, then because of air leakage being higher than it should have been, then if it had an air leakage of 5 and someone claimed that it was 3, or satisfied AECB building standards, then there would be issues that would need to be addressed there. So no, I'm not aware of anybody being sued, but
that's fine. That's fine.
Away.
All right, next one. Once you get the so this is from Marina Tapuzzi. Sorry if I've pronounced that wrong, Marina. Once you get the AECB certification standard, is this for the building lifetime? And what happens in CE that replace, measure, or need to intervene to the fabric?
Okay. Right. Well, basically, it's a design assessment at that point in time.
I'm supposed to say in case. She's just, sorry, Marina has just replied. So it's supposed to say, once you get the AECB certification standard, is this for the building lifetime? And what happens in case? Of
replacements.
That replacement measures a need to intervene to the
fabric. So basically, what the AECB Building Standard, like all the standards, is effectively a design standard, but it's supported with also some construction-based evidence as well. And that's what makes it different, but more akin to Passivhaus, because we're actually getting the commissioning reports and the air tightness reports. So it is a design. It's basically at that point of completion that the building is certified based upon a review of the drawings, supplementary photographs to show that the building has been built in accordance with the AECB Building Standard. There's a as per Passivhaus methodologies, when the builder contractor would confirm that they have built in accordance with the contract documents. So we're assessing the contract documents in the PHPP model, and then we've got that supporting information. And then if somebody makes changes to the building at a later date, then there's no guarantee that it's going to keep achieving the AECB building standards, because you might have replaced a window and also influenced the air tightness, for instance. So you could ask for another review at a later date, and to assess whether it's still it remains within certification, should we say?
Okay. And then from Kathy, can this approach be used for retrofit, where you have an extension built to low energy standard and some improvements on existing house, but to a lower standard?
You can, basically you can build a model. Well, when you're dealing with an existing building, first of all, I would say that you need to consider this as part of an overall building retrofit program, and therefore you want to be looking at that whole house retrofit approach, and the extension would be a part of that. So what that would mean is that the extension can be built to work to the AECB Building Standard. And that, but the retrofit, retrofitting the building as a whole should be a part of that design process, even though it might not be within a kind of a singular budget. It would give you a way of thinking about how you would then approach the rest of the building in due course over its life cycle.
Brilliant. Okay. And this is from David Moore. In order to comply with the AECB daylight factor requirements, does the AECB tool need to be used, or can other third-party software such as Dialux be used, i.e. is admissible?
Yeah. So in terms of actual certification to the AECB daylight standard, then it's using the PH ribbons and daylight tool, which is kind of the requirement there to make sure that we're benchmarking things in a kind of comparable way, shall we say. That's the process. As I say, there are other tools out there that can make daylight assessments.
Okay. And okay, I'm going to jump into a chat question now. So this is from Jessica Hay. We're working on a 55 home D&B project, which is being done with the standard, but not any of the additional water, daylighting or carbon components. The project is already on site. Can these be added in at a later stage under the scheme?
There's no reason why they couldn't, should we say, or you could at the very least assess. You can run those assessments and then see where you fit, and if you satisfy the performance criteria, then fine. If you don't, then the key that you would still have a compliant building because you satisfied the energy performance requirements.
Okay. And Ben Owen asks, how does this standard relate to retrofit projects? Are there relaxed fabric targets?
Well, the AECB Building Standard has been used by some pioneers, should we say, to inform their approach to retrofit. So the 40 kilowatt hours per meter square per annum target allows you to then look at where where and how you would insulate a building in appropriate ways, and so I think that it does provide a framework for achieving appropriate kind of performance, but the key thing there is recognizing the spacing demand targets there. It's not that there are more relaxed value values necessarily. What we need to be thoughtful of when we're dealing with a retrofit is appropriate insulation. So are we putting it on the inside or the outside, and how does that have an impact upon moisture? So it's not a case of simply targeting the AECB building standards for retrofit as an energy model. You need to be thinking about moisture issues as well, and that might mean that if you're putting insulation on the inside, the U values that you achieve on the internal, for the internal insulation are higher, less good, and therefore you need to trade off somewhere else to compensate for those deficiencies.
Okay, that's good. Thanks, Mark. Question from Joe Burlington. AECB standard is energy demand in per square meter. The Jevons paradox. In the long term, an increase in efficiency in resource use will generate an increase in resource consumption rather than a decrease. Planetary threats are horrendous, so there must be limits, e.g. wartime rationing, speed limits. There needs to be consumption maxima, a fair allocation of housing space per family, and something like tradable energy quotas, TEQs, or our children will suffer. Not sure if that's really a question, Mark, or more.
No. I think the only context here that I can respond to is just the Jevons paradox, and it's the one whereby when we retrofit buildings, it's been seen as well that basically people have been living in fuel poverty. They haven't been able to heat their homes to the point whereby they're comfortable. And I think that what we need to be able to do is heat buildings so that people are comfortable. And that if that means using a little bit more energy to do so, that's that's okay, because they've been in some dire circumstances previous. We should all have the same right to the same levels of comfort as much as to anything else. And then it's a case of making sure that we've designed the building appropriately to minimize those carbon emissions through getting the U values, the fabric right, and making sure that we've then tied that up with any air source heat pumps tying into an electrical grid that will be gradually decarbonized, and that sort of strategy.
Okay, thank you. And okay, Dom Cox, again, this is more of a comment, but the toxic escalation of value in the property market is unlikely to be dented under this government, even after Brexit. While the fashion for net zero dwelling among the property owning middle class increases, currently the market is dynamic due to COVID exodus from town centres. The P2 risk on the certifier is potentially huge, especially if any, I can't even pronounce that word,
polyisocyanoate insulation.
Yes, well done, Mark. Got one. Is specified, such as Kingspan. Do you want to comment on that?
Well, you said P2. I think that was professional indemnity insurance. And that, I was looking at the question and it just disappeared.
I think Andy's answering some live, which is why you're seeing them disappear.
Right. So I was trying to pick. So right. I mean, the AECB Building Standard can't tackle issues in terms of values of properties and attitudes towards that. And there's nothing about the AECB Building Standard that encourages the use of toxic insulations. If anything, it's the opposite. The attitude is to look after people's health and well-being primarily, and reduce energy use in the process. Okay.
And the last question at the moment, and this is more of a statement again, why AECB Energy Standard? Because there are a huge number of existing houses which would not be suitable for full passive house, but which benefit hugely from a carbon light retrofit. This would also help with overall national energy use from a PE perspective. Is this not an important area of work on which to focus? So it is a question, sorry.
Yes, retrofit is important. And that's why pioneering types are using the AECB Energy Standard, AECB Building Standard, to support their projects, being mindful of moisture issues and other secondary impacts of undertaking a retrofit. Because of course, the AECB Building Standard, air quality is kind of absolutely critical, which is why we have the opportunity to use MEV or MVHR in the property. We don't use natural ventilation because it doesn't work. It doesn't deliver the standards of air quality that are expected in a good building, basically.
Okay.
AECB Building Standard, because it ties in with retrofit for sure.
Brilliant. Is it worth just touching on quickly, not in great detail, just about the AECB are actually producing a retrofit standard now, and that will be ready quite soon?
Yeah. Well, that's it. There is an AECB Building Standard that's a retrofit standard that's under development at the moment, and it's still being tailored. Whether it still sticks with the 40 kilowatt hours is something that will be is one of the things that's going to be reviewed. But yeah, it's under development and will be out into the real world before too long. I'm not going to try and give a date because I don't want to put anyone's feet to the fire necessarily.
That's good. Okay, well, we've answered all the questions, Mark. I just wanted to say you've had quite a few comments from different people through a private chat saying that it was absolutely brilliant webinar, very informative. So thank you very much, Mark, for your time today. For everyone who's attended, thank you for coming. The webinar will be up within the hour on the webinar recordings page on the aecb.net. And yeah, thank you everyone for coming again. Thank you, Mark, for your time. And we look forward to speaking to you again in maybe a follow-up webinar.
Certainly. Yeah, no, happy to help.
Excellent, brilliant. Okay, thank you everyone for coming. Bye for now.
Take care.
Cheers, bye, bye.